On number 7, I'm trying to solve this using Gaussian elimination. And I need to get a 1 in front of this x. So this is something we haven't had to do yet. So I'm actually going to swap equation 1 and equation 2, because equation 2 already has a 1 there. So there are different ways of doing this. So you could multiply equation 1 by 1/2, which would be fine here, here, and here. But here it would introduce a fraction, and I don't want to deal with fractions. So I'm going to swap equation 1 and equation 2. So this is going to be x plus 2y minus 3z is equal to -4. The second one is now going to be 2x plus 4y minus z is equal to 2. The third one is going to be 3x minus y plus z is equal to 1. So my next step is going to be to eliminate the x in my second equation. So I'm going to do equation 2 plus -2 times equation 1 to be the new equation 2. So that's going to be 2x plus 4y minus z is equal to 2, -2x minus 4y plus 6z is equal to 8. And if I add those up, then the x's go away and the y's go away, and I'm left with 5z is equal to 10. So let me copy my system so I can move it to the next slide. And it looks like some other stuff came with it. There we go. So everything is staying the same here, except for I have updated my second equation. So my new second equation was 5z is equal to 10. Now, I wish that was in the third equation, because in my third equation I want to have only z, and I have that in my second equation. So I'm actually going to swap these. So let's swap equation 2 and equation 3. So equation 1 is staying the same. And equation 2 was our old equation 3. And equation 3 is our old equation 2. So the last thing that's left to do is I need to get rid of that 3x in the second equation. Again, my goal is to create a triangular system. So equation 2 plus a -3 times equation 1 should do the trick. So this will be 3x minus y plus z is equal to 1, then a -3x minus 6y plus 9z is equal to 12, and And if I add those up, I'll get negative 7y plus 10z is equal to 13. So all of my equations are staying the same except for equation 2 is now going to become negative 7y plus 10z is equal to 13. So now I can just back substitute. So z is going to be equal to 2. If I plug that into the equation above it, and I solve this, this is negative 7y plus 20 is equal to 13. Negative 7y is equal to negative 7. Y is equal to 1. And then plug those both into the top equation. So we'll have x plus 2 times 1 minus 3 times 2 is equal to negative 4. So that'll be x minus 4 is equal to minus 4, or x is equal to 0. So my final answer will be 0, 1,